Hello, and welcome to the introduction of CyberMapper Aggregator. Specifically, we're going to talk a lot about delivering the SDN, software-defined networking concepts, to the packet broker arena. And we're going to focus in on our key secret sauce, which is the agent pipeline on there. But first, I thought we'd do three kind of introductory slides to frame where we are, what we're talking about, and then drop into the actual functional detail and how the algorithm works. So to start with, this slide presents, what our key features are and who we see ourselves competing against, and that's organizations, network operators, and intelligence organizations would buy the aggregator over the NetScout or Gigamon products in this space because of these 6 things. And the core of that is, of course, right here in the center. First is the agent pipeline, which is our unique algorithm that makes programming the Tofino, which is our chip used in our switches, makes a programmable Tofino chip easy to manipulate, easy to create specific pipelines to solve your problems in the packet broker world. And this is really dynamite. This is next generation SDN solutions for packet broker and analytics tools. Also, a key to that in this agent pipeline is modularity. This is just the standard computer science, take a big problem, break it down into smaller problems, think object-oriented programming. When you look at the agent pipeline, you'll see that that's exactly what we do. We break it into a number of smaller problems, that are easy to craft solutions for and easy to maintain. Then, of course, we see that the biggest thing, the network's changing incredibly rapidly out there, and we don't see these packet broker agents in the marketplace. The tools, around this. Exactly where we are is moving that fast. And we see customers coming and saying, we want to do new things. We're having to do bit offsets to get our current tools to work. So in a successful engagement here, we're going to be able to offer you something you can't get from the other vendors. And that should be fairly clear as we go through here. On the other side is just huge throughputs. We're talking multi-terabit throughput on this, all the way up to 6.4 terabits in the products we have now, and higher speeds coming very quickly from Intel Barefoot out there. But this is a very powerful environment that runs at massive throughput rates. And then another part that is kind of what we already talked about, but we're really going to focus in on this in the presentation, is how easy it is to learn. It's incredibly powerful, but that capability doesn't come with an increase in difficulty of using it. We've actually made it easier to use. So with that, you have the core positioning on that. So let's take a quick look at the next section. Now we're going to talk about where do we fit. The packet broker space is big, and it can mean, when you say packet broker, you can mean a specific device in that kind of network, in that domain, or all of it, and it gets interchangeable. But where we work is right at the center, right here. So if we have the taps and spans to the left, that are gathering information, gathering the flows and sending them in, we then have the broker that takes all those flows, allocates them out to the tools here on the right, and that's where we are. We're right there. We don't provide any of the tap technologies or span technologies, and we don't work on any of the analytics or visibilities or AI devices out here. We take this huge flow in and aggregate it out, send it out specifically in the right size, mirrored, load balanced, whatever, across all these things in a very, very large group. So this is where we work. Down here, you'll see more of these. The little Sankey diagram that starts to give you the first look is, as packets flow through our aggregator, how do they get divided up and ultimately, filtered and then load balanced or mirrored off to the right tool set. So that's where we fit in there. We can create new features, but more importantly, the customer can create new pipelines of how the stuff flows through their stuff by the configuration process that we've adopted. And that's, we have this idea of agents that we'll come through in a minute, which are, think of them as templates of what you can do at certain stages and how fast that works. So that, the SDN approach we've talked about, flexible output tools, we can load balance or we can mirror to the stuff, picking the right process to the Tofino or to anything else that runs P4. The parser in the Tofino is probably the most underrated part of that chip. It is magic. And what it does for us is it allows us to parse complex sets and get all the stuff on the inner packets of the ones we support right now, which is a ERSPAN out there. And then that runs through as metadata. So we don't ever have to do bit offsets because we know those bits by name, and that all comes out of the parser. Yeah, we can look inside the MPLS stuff. We can look at, we pick apart those ERSPAN. This is really powerful. Okay, so now we're going to shift and we're actually going to talk about how do we deliver this? What does this look like? And most specifically, how does it empower the user? And the idea here is that we're going to divide this up. So here the ports again are where the taps, tap traffic shows up. So we talked about taps on the left, and the ports here are going out to tools. And this is what CyberMapper does already. Load balance. We've added a distribution where we mirror to everything, and so this could be like big AIs, that are two different sets of AIs, boxes that want to see the same thing. So the right and the left, the tools and the taps. In the middle, we're going to break this problem down into, as stuff show up on a port, you're going to have 4 bites at the apple. We're going to call these things agents, and you can think of them as a little template. We'll actually show some of them in a minute, and you'll understand how small they are. But it's what gets done at this stage, and you define it in a stanza of a YAML file, a few lines. So in general, I'm going to say, and we'll drop down to, in this stage, in the Ingress groups, we're trying to aggregate stuff up that's the same. So if I've got taps coming in from 3 different, if I got them from London, from Ontario, and from Montreal, and they're all coming off the handset side, they're exactly the same type of traffic. I don't want to have to write different rules for each of those. So I can aggregate all those together. So this allows you to take a lot of streams and put them into a few streams so that all the processing down the pike can be more efficient. You only have to do it once. We make sure by the way the taps are placed that you never see the same packet twice. We'll show some examples, but actually how we filter. So the most simplest example there is when it shows up, just after it hit a CO, it's going to have an MPLS depth 2. And so if we have a tap right next to the gateway, if it's MPLS, and we see a packet and it's MPLS depth 2, we know it just came in. If it's anything else, we know it's headed out. So that's how we partition the flows, so we never count to the same packet or know where they are. So this first agent is to group them, and we'll tell you a little more. The second one is to apply the filters on the outer header. If the packet is not encapsulated, that's the only header. If it is encapsulated, we can do things out there to look at the outer header, but a lot of times we're going to want to look at the inner header. So in that case, we'll just mark it as, hey, this is an encapsulated packet. The third agent can look inside of an encapsulated packet and deal with the real source and destination, and you can look at the real packet. It doesn't have to tear it apart to do it. We've already done that. And then the fourth agent, and then sometimes it's used if if it's not an encapsulated packet and you want to get a second byte, put more filters on, you can do it there. But the main purpose, it's sitting there for encapsulated packets. And then the toolset agent does what I just said. It's lets you add tools to a tool group and then sprays them out or mirrors them out. So let's take a quick walkthrough of these. I'll explain what this guy does, and this will become a little clearer. So so in the next 4 slides, we're going to try and give it a feeling of what is going on here at a level somebody could say that's really interesting. And so each one of them will have a main features and then kind of key features. And so this is what I just talked about. This guy, these sets combine tap streams, of similar flows, and that is totally up to whoever to do that. You can have more or fewer of these, and then put a name on it. So think of this as a template. This says, okay, at this stage, using this agent, I can do certain things, and we'll show you what that looks like. And then when I do that, when I combine these things, I can put a name on it. So this is using an Ingress group, and we've used it to combine these 3 ports, and the client is calling it Ingress 1. You could call it, Snap, my name of my dog. It's up to him. So these are 3 instances of this type of agent, in there. Okay, and then a limitation, a port, because we get this asked all the time, can belong to only to one Ingress group, out there. So, all right, the next one. So the main functions now, on this, first thing is, all right, for this instance, where am I getting my data? And that's, registering for, okay, I'm going to get my data from Ingress group 1. And then I'm going to filter on it. And we have a huge number of filters you can do. What's really interesting is you can filter by field values, like what is the source IP or destination IP or protocol. But you can also filter on shape. The shape of the packet would be, is this packet encapsulated in MPLS level 2, not MPLS 1, not 3, 2, and only that. So in this case, I would be getting my data from here, and when I put my filter on, is now selecting those, and there'll be a whole bunch of them that it doesn't select, and we'll talk about what happens to that. So if nothing gets selected from this Ingress group, anything that doesn't match an Ingress filter just gets dropped. Okay, and then we can stack these. So this is you'll see an example of a stack, and we'll talk about it in a little bit. And we can name them. Again, these names are customer names. Then the key features, again, are we register to a group. So this says I'm going to get my data here. This guy says I'm going to get my data from here and here. He's registered to 2. We filter on specific packet characteristics. Packets that aren't matched in any of these in the stack get dropped. And the other feature that we have here is we can mark this packet as encapsulated. And so if it's coming in with a earthspan encapsulation, which is where we're getting the majority of our traffic, or we're getting a lot of it, or if it's coming in with an MPLS2 encapsulation on it, it gets an encapsulation flag, and then that will enable some features in the next stage. Okay, next stage. Packets have now gotten through. They've been grouped. They've passed this filter. They now go into the egress filter side. And here we're showing that we have, the client has crafted 2 egress agents, interest 1 and interest 2. So in here, we can match on the inner packet. We can do this second match, and think of this as an AND condition, if we don't have an inner packet. So some complexity you can do. And this group also forwards the stream to the toolset, or replicates them to many toolsets. So we don't have an example in this simple one, but if I match here, I can send it to this guy and to this guy. So I'm getting into multiple tool sets. The way this works is very simple. That the agent, when you see the stands, you actually see the agent has a priority in it. As the packets come across when they're going through the pipeline for us, we will process them in that priority against these agents, and the first match wins. So if the packet comes in from here and doesn't match there, he'll go there. If it doesn't match there, he'll get dropped. If he comes in and matches here, he goes out. This guy never sees him. So this is, you can only match once, and the first time you match, a decision is made of where you're going to go. But when you get in and you get clever, you can do really, really interesting things here. And we have a cookbook that talks about a bunch of those. And then, of course, the last one, this is just a CyberMapper functionality. The packet now shows up at a tool set. We can load balance or we can multicast. In this case, we're load balancing 1, 2, 3, 1, 2, 3, 1, 2, 3. In this case, we fire them off to both. The customer, again, can give their names to the stuff. So we actually replicate in 2 spots. At this match, I can send it to multiple tool sets. At this, in a tool set, I can be load balancing or mirroring. So if it's a mirroring, I'm sending it off to every port, every tool identified in that set. This could be where you're running complex AI and you've got one big device running AI of type 2 and you have another device running AI of type 3, and you just want any packets that arrive here, you want them to go to both devices. This one's a standard. You have DDoS, and you got DDoS engine 1, engine 2, engine 4. And these can come and go. They're HA, all those things. Okay, so that in this one, we're thinking a lot about how do I pass it from agent to agent. We said the end user can craft their pipeline. Well, this is their pipeline. This, they started with a blank sheet of paper and they said, these guys are going to go through this. These guys are going to go down here. And that was their choice. Now I'm going to shift gears and we're going to talk about why this is so powerful, but we're going to look at it from the packet flow, which is really interesting, and a thing called a Sankey diagram, which is fairly old, but very, very widely used. So we want to spend a second talking about, okay, we said we had agents. What's the value of that and stages? Why should Chris or any user care? Well, because it's at the heart of everything done in computer science these days. You take a big problem. I've got billions of packets coming in from taps on one side, and I've got a dozen or more tools on the other. How do I get them to each other? If you make that one programming choice, it's complex. You're picking them, you're filtering them, you're load balancing, and if you look at those tool sets that do all these big rules, they're very hard to follow. So in our case, this is just the heart of everything. We took a very big problem, we broke it down into 4 stages. You concentrate on one stage at a time. So it's modular, it's object oriented. By that, what I mean is, if I'm back here, and I get a 4th port, I just change the port structure in this thing. I don't change anything else anywhere else. I don't care how many filters, taps, all that other stuff continues to work. Same here. If I get a different tool, I just change it right there. So that's all the goodness that's in object oriented. And each agent can be modified in isolation. The proven benefits everywhere is, in object-oriented programming, it's faster, it's easier to code, it's easier to understand, it's easier to maintain. This is a very powerful strategy and technology that is a pick, and it's a much different pick than working on Broadcom. These agents are a very high-level interface to the silicon. And the way these agents got put together was that we went in and looked at how we would use the Tofino chip to solve this problem and how we would do it better than Broadcom. And then from that's where the 4 stages came from. We looked at it and we said, okay, how do we summarize that again one more time and make what we're doing in those 4 stages easy for the end user to craft? And that got us to, okay, we're going to have a configuration file. We're going to use a YAML file because it has some very wonderful features. We're going to make it easy to understand. And if you actually look at the code, this, what we're calling an agent can be hundreds of entries in the Tofino chip. So this very simple set of code that they write, that they craft, explodes out into very big rule sets inside the Tofino chip. But we handle all of that. We're now going to look at this. We have our 4 stages again, but we're going to track by flows coming in. So this is, we just took an example. So we're going to run through the same pipeline, but here we have 3 taps and each of them are sending us 3 gig. So we got 9 gig here, and then it goes to 9 gig, and then we pick 6 and 1, and some drops off, out there. So this is a flow diagram out there called the Sankey diagram, showing you where it drops, how it gets aggregated, how it gets allocated, where it gets mapped or load balanced out there. Here's where we go from just hyperbole to I can do that. So we're going to talk about how complex is it to build an Ingress agent group. So the Ingress agent that we talked about wants to map ports into an aggregate agent, an Ingress grid instance, and wants the name of it. And so you do all of that in these 10 lines of code. It says, here's the agent I'm working on. Here's the name I'm going to give it. And oh, by the way, I have 3 ports. Now, could it be any simpler? So in our example, we handled all of the ports with 3 statements like this. With Ixia, I've got 5 or 6 conditions downstream. I'm going to see this port in 5 or 6 different rules. Here we see it in 1. And like I said, who looking at this presentation would say, oh, that's too complex for me to write? So that's the Ingress group. Now we go over here and we say, okay, we're going to have an Ingress filter. So we want to tell it where we're going to get the data, and we want to make a selection, and then we want to give it a name. So, okay, here's the name we gave it. This is the priority I talked about. Here's where we're getting our data. And oh, by the way, here's our rule. We're taking anything that is MPLS depth 0. So in this case, we're looking at the shape of a packet. We don't care what its source IP or destination IP is. We just know that if it doesn't have MPLS encapsulation, it's not coming from the outside, and we want to know what packets we're sending out. And this is how we grab all of them. This is 6 lines. How simple could it be? Now, there's lots of things you can put in here, but whatever you put in there is straightforward. Anybody doing anything that grabs IP4 addresses would know how to program that. Great concept, very powerful, absolutely unbelievably easy to implement for the end user. We go to the next one. Now we're going to show you a little more complex filter, but it's the same stuff. So now I'm getting packets in. I'm going to want to look at this range of address, with this mask. I'm going to want to send them to Toolset EG0. And I want to give this guy this name. This is the code that does that. This is the YAML file, configuration file that he writes. So now the priorities, and we talked about this, is how the stack gets processed. So if there's a priority 100, it would get processed before this stanza. If there's a priority 200, this guy gets the first byte at the stream. If he gets a match, it's gone. If he doesn't, it goes to the next one. We've got ranges, but we also now have IP lists. So this is a specific match. We also, you can get it with a cedar thing, so it would be just /8 there, and the tool sets. And then the last one is, of course, okay, we've got a tool set. All right, this tool set here has its name, has 2 ports on it. It's a load balancer. We're going to send it out. So that's the walkthrough of the product. And what we wanted to do is we want to show it's a new concept. It lets you attack complex tap to tools situations, where you remember, if I get a big tap from London, that will have IPMC traffic, it'll have ARP traffic, it'll have handset traffic. It has all these different things. So I'm going to want to carve that up a whole bunch of ways, so it can get real complex out there. But we let you handle that with very simple statements. And we wanted to show that, hey, this is what an agent looks like. It's not a big fancy thing. It's not 200 lines of code. It's here's what you can do in a YAML file. And so it really works. So our goal there is to make it more flexible. We let you define your stuff. We let you do it quicker. We make it so it's maintainable and you can bring new guys in to read it, and then actually show them some of the stanzas so that they said, yeah, I can do that. So now we're going to say, how can you get it delivered? So this is just how can you get it out there? And we've got 5164 to 5132. You can order this today and install it tomorrow.